Bismillah Rahman Rahim. In this session, we will discuss electromagnetic spectrum from O-level physics. This book is written by Tom Duncan and Heather Kennett and published by Hodges Education. Electromagnetic spectrum is a visible light forms only a small part of a very wide spectrum of electromagnetic waves. So the visible lights that we see is only a small part or a small part of a very wide spectrum of electromagnetic waves, all of which travel with the speed of light in a vacuum. In a vacuum, all electromagnetic waves travel with the speed of light. So they all travel in a vacuum with the speed of light, and we see this is from this range to this range. Here we have seen that the electromagnetic wavelength is increasing, and here we have a shortest wavelength, here we have a longest wavelength. Increasing wavelength is increasing. On the other hand, the frequency is increasing on the opposite side. So this is the least frequency and highest wavelength. Here we have a least wavelength and highest frequency. So this is the gamma rays, X-rays, and then this is ultraviolet light and infrared. So this is visible light, and then microwave, radio waves, and then radio signals. So the wavelength of gamma rays are in nano or micrometers. So this is nanometers and this is in micrometers. So the lights are in micrometers, and afterwards this microwaves is in millimeters range, while radio waves are in meters and radio signals are in 1 kilometers wavelengths. So the radioactive matters sources. So this is X-ray tube. For this X-ray, we have this X-ray tube, this gamma ray from radioactive materials or matters. This lights simple mercury lamps, and sun is create this band, electric fires, this microwaves, micro oven, this is transmitting TV and radio aerials. So these are some of the sources which generate this kind of electromagnetic spectrum. And light is one member of the family of the electromagnetic radiation, which forms a continuous spectrum. So this is continuous spectrum. So light is just a subset of this whole set, just a small part. This is a visible light. It is a member of the family of electromagnetic radiation, which forms a continuous spectrum beyond both ends of the visible light spectrum. Figure 3.331 shows the main region of the electromagnetic spectrum with their corresponding wavelength. Note that the wavelength increases from gamma to the radio waves. From gamma to the radio waves, the wavelength increases, as we can see, while the frequency increases in the reverse direction, from radio to gamma. From radio to gamma, the frequency increases. Gamma has the shortest wavelength and highest frequency. The radio waves have the largest wavelength and lowest frequency. This is all shown in this figure. So this figure is very, very important. While each type of radiation has a different source, all results from the electrons in atoms undergoing an energy change, and all have certain properties in common. So we have seen this all different radiation sources, this electromagnetic spectrum generating sources. The properties of electromagnetic waves. All types of electromagnetic radiation travels through a vacuum with the same high speed as the light does. So the electromagnetic radiations travel through a vacuum with the same high speed as the speed of the light. The speed of electromagnetic waves in a vacuum is 3 into 10 to the power 8 meters per second and is approximately the same in air. And in the air, this speed is almost the same as this. They exhibit reflection. This electromagnetic waves exhibits reflection like light and waves. So reflection, refraction and diffraction, and have a transverse wave nature. And the nature of this light is transverse wave nature. They obey the wave equation V is equal to F lambda, where V is the velocity of the light, F is the frequency, and lambda is the wavelength. Since V is a constant in a particular medium, it follows that large F means small lambda. If F is large, then lambda is small. If lambda is large, then F is small. They carry energy from one place to another and can be absorbed by matter to cause heating and other effects. These electromagnets carry energy from one place to another. They can be absorbed by the matters to cause heating and other effects. The higher the frequency and smaller the wavelength of the radiation, the greater is the energy carried. If it carries higher frequency and smaller wavelength, the greater the energy carried. Gamma radiations are more energetic than radio waves. So that's why gamma energy, because the frequency is so high, so it carries more energy as compared to the radio waves. Because the electrical origin, its ability to travel in a vacuum from sun to the earth, and its wave-like properties, electromagnetic radiation is regarded as progressive transverse waves. Electromagnetic radiation is regarded as progressive transverse waves. The waves is a combination of traveling electric and magnetic waves. This electromagnetic radiation is a combination of traveling electric and magnetic fields. These fields vary in values and are directed at right angle to each other, and the direction of travel of the wave as shown by the representation in figure 3.32. So this red is basically the magnetic field, and this blue is which is perpendicular to the 90 degrees. If this is on this angle, so this blue is always is in 90 degrees, creating an angle of 90 degrees orthogonal to this red one. So this is electric field. So they are traveling simultaneously with a degree with an angle of 90 degree apart. So light waves is a visible spectrum. Red lights has a longest wavelength, 0.007 millimeter, that is 0.7 micrometer in the micrometer range. So this is 0.7 micrometer. And violet lights have a shortest wavelength, 0.004 millimeter, which is 0.4 micrometer. 0.7 micrometer and 0.4 micrometer. Color between these in the spectrum of white light have intermediate values. So the other wavelengths are covered within this 0.7 to 0.4 micrometers. Color between these in the spectrum of white light have intermediate values, and since V is equal to F lambda, so red lights have lower frequency and violet lights have higher frequency. Lower the wavelength, higher the frequency. All colors travel with the same speed. All colors speed is same. It is the frequency of the light which determines its color. It is the frequency of the light. Frequency of light determines the color rather than its wavelength, which is different in different media. So color is determined from the frequency of the light, not from the wavelength. Different frequencies of light travel at different speed through a transparent medium. Different frequencies of light travel with a different speed through a transparent medium, so are refracted by different amounts. When it passes through a transparent medium or through another medium, dense medium, but they are refracted by different amounts. This explains dispersion. This is called dispersion. In other words, why the refractive index of material depends on the wavelength of light. So according to the wavelength of light, it gives a different kind of refraction, and as a result spectrums are developed and is called dispersion. If light intensity increases, brighter light become brighter. In addition to vision, light is used for illumination and photography. In addition to vision, light is used for illumination and photography. Now we will discuss this put into practice question on page 160 in the next